All right, in this section, we're going to focus on three problems that look at functions and we're going to, in number 5, we're going to check to see if this function is one-to-one. In number 6, we're going to look for the domain. And then in number 7, we're going to evaluate the function at different places. Okay, so in the first one, what we want to do is we can do a few things. We can think about uh, this equation and say, what is its kind of base shape? Well, notice that the x is being squared, and so our leading coefficient is 2, or sorry, not our leading coefficient, our degree of the polynomial is 2. So we have a parabola. It's open up. So we already know that if we have a parabola, it fails the horizontal line test. So it's not one-to-one. But how can we show that? Well, one easy way to show that in a parabola is that if we can find the vertex, then we can kind of move an equal distance on either side, and then we'll show that two different inputs go to the same output. So that's what we're going to do here. Now, if you think about this, we have three things happening. We have a horizontal shift, we have a stretching, and we have a vertical shift. So we want to figure out, where is that vertex? Well, if we just had x squared, f of x equals x squared, then our vertex would be at 0, 0. And even if we had 3x squared, our vertex would still be at 0, 0. But now we know that we have a horizontal shift. So when I look at this, say, what gets me back, what x value would get me back to 0 here? And since that would be negative 2, I know that my vertex has an x value of negative 2. And then I can also say, okay, well, if I put in negative 2, that gives me 0 squared, and multiplied by 3 is still 0. And I've done that shift up 1. So I have this vertex. Now, an easy way to determine whether my function is that, like I said at the beginning, I'm going to just move over and I'm going to evaluate where x is negative 3, and I'm going to evaluate where x is negative 1. Notice I'm just moving 1 to the left and 1 to the right. So when I put my pieces together here, negative 3 plus 2 squared 1, and here I have 3 times negative 1 plus 2 squared plus 1. And I don't have to go very far. I'm just going to simplify a little. So I have negative 3 plus 2, so that's negative 1, and that's being squared. So I have negative 1 squared plus 1. Here I have 3 times negative 1 plus 2, that's positive 1, squared plus 1. Now notice I'm squaring negative 1 and squaring positive 1. So clearly those are going to end up being the same value. And since everything else is the same, my two inputs lead me to one output. And so I don't have a one-to-one situation. Is it one-to-one? No. All right. Let's look at the domain. Now if we're talking about the real number line as inputs, then here I want to figure out what situation doesn't allow me to have real numbers for my output. So if I put in, so since this is a square root, I need to make sure that the thing within the square root that I'm evaluating is not negative. Okay, so what I just said is that I want the part inside that's being that has the root taken is not negative. So not negative means it's greater than or equal to 0. Okay, and then I can just go through the process of solving this. I subtract 5 on both sides, and now when I divide by a negative 1, I'm flipping things over. So I have to flip my inequality. And so now I see that my domain are the x's that are less than or equal to 5. And another way I can write that is negative infinity to 5 and including 5. And that makes sense, right? If I put in 5, that's the biggest number I can get, I get 0. If I put in anything less than 5, say 4 or negative 20, I'm subtracting a negative 20, so I'd be moving into the positive direction. And clearly anything, like if I put in 10 or something like that, I get a negative number. Okay, and now let's look at number 7. Number 7 is another evaluation problem. It's just kind of complicated. So I have the function evaluated at this place minus the function evaluated here. So like I did before, I'm just going to rewrite my function, leaving space open for that. Then I'm subtracting my whole function. So I'm subtracting the 3 square plus 4. Okay, that's a plus. Okay, so now I'm just going to put in the pieces of the evaluation. So here, a plus 2, and a plus 2, and here just 2. Okay. So all the bit that I'm subtracting is just going to end up being a constant, so we can work that out pretty easily. So we get 2 squared, which is 4, and 4 times 3 is 12. So we have 12 here, and then we have 4 times 2 is 8. So I have 12 plus 8, so I'm subtracting 20. Okay. And here, pretty straightforward, I have 4a plus 8. And then like we talked about before, when we're squaring a binomial, we need to make sure we deal with the middle terms. So I have a times a, which is a squared. I have 2 times a, which is 2a, and then I have another a times 2, which is 2a, so we have a 4a, and then 2 times 2 is 4, and that's added on to that. And then as I distribute that through, I get 3a squared plus 12a plus 12, now plus 4a plus 8 minus 20. So now I'm just going to combine my like terms. I get my 3a squared. I have 12a and I have 4a, so now I have 16a. And I have 12 plus 8 gives me 20 and minus 20, so I don't have a constant term anymore. So my result, this whole thing evaluates to what I have below.